Okay, today we are going over 11.5 day 2. Our essential question is, how do you find the area of complex shaded regions? And on the paper you will find 4 examples where some or all of the shapes are shaded. If we look at this first example, it's made up of a square, and then we have 2 circles on either side of that square. So half of each circle is inside the square. So when we're looking at this, we may want to find the area of the square, because that is what is shaded in. Okay, and then the part that's cut out looks like half of each circle. But if I put a half of a circle with a half of a circle, that's the same thing as a whole circle. So I'm just going to do the area of one circle that I'm going to subtract. The area of a square is quite easy. The base is 6 and the height is 6. Those are both given to us. The area of the circle is pi r squared, and I'm given the diameter, so I need to cut that in half before I square it and multiply by pi. So this is going to be 36 minus 9 pi, and when I plug that into my calculator, I'm going to get 7.73 meters squared. Remembering that we need to label all of our answers when we're talking about area. Looking at this second example over here, it kind of looks like an L shape. It's made up of a square, part of a circle, and a rectangle. So my plan is to find the area of the square. Since it's easier for me, I'm going to find the area of the rectangle next. And then I'm going to add the area of that part of a circle. So now I have to decide how much of that circle, and it looks like it's a fourth to me, so I'm going to divide the whole area by 4 to get only a fourth of that. The area of the square is going to be 3.5 times 3.5, base times height. The area of the rectangle is going to be, the base is 7 and the height is 3.5. And the area of the circle is going to be 3.5 squared times pi. When I go back to my calculator and plug this in, 3.5 times 3.5 is 12.25. 7 times 3.5 is 24.5. And 3.5 squared times pi, and I cannot forget to divide this by 4 because we only want 1/4 of that circle, happens to be 9.62. When I add all of these values together, it happens to be 46.37 feet squared. Looking at this next example here, looks like we're covering up a little bit, so we'll fix that. This is a trapezoid, and so we need to find the area of a trapezoid, and then we're going to subtract the area of this circle that's cut out, and there seems to be only a half of a circle there, so that's why we divide by 2. We're kind of just try to adjust this so that we can see what we're working on here. Okay, so the area of a trapezoid, I need to add the bases together. The top is 30 and the bottom is 18, and then I need to multiply by the height and take all that and divide by 2. And then subtracting the area of half the circle. So the radius of the circle is 5, and I need to square that and multiply by pi, and then not forget to divide by 2. 30 plus 18 is 48, times 10 is 480, divided by 2 is 240. When I plug 25 pi divided by 2 in my calculator, I get 39.27. When I subtract these values, I get 200.73 inches squared. Moving on to example number 4. This looks to me like it is a circle with 2 small sectors shaded. So it looks like I just have to find the area of a small sector and then multiply it by 2. Okay. To find the area of a small sector, I do have to find this angle right here. But this is a diameter, so I can easily do that by taking 180 minus 112, finding it to be 68. So the area of the small sector we don't know. We know that the area of the whole circle is going to be 6.3 squared times pi. I know that my angle for my sector is going to be 68 out of 360 whole degrees in the circle. To solve this, I need to cross multiply. So when I multiply 63 squared times pi times 68, I get 8,478.9072 is equal to 360x. When I divide by 360, I'm going to get x is equal to 23.55 inches squared. Now I need to go back and remember that in my picture I have two of these shaded areas. So I need to multiply my answer by 2, and my final answer will be 47.11 inches squared, because I had to double the area that I found. Looking at examples number 5 and 6, they look a tad bit difficult. Looking at example 5, it seems to be a bullseye and a series of circles alternating which one is colored in. I've numbered the circles 1, 2, 3, and 4 so that I could denote the differences between them. So we'll start by finding the area of, with the area of circle 4. We then have to subtract the area of circle 3 because it's not colored. We have to add in the area of circle 2 because it is colored, and subtract the area of circle 1 because it is not colored. When I go to actually find the areas, I'm going to start with the area of circle 1 because it's all the way on the inside and it seems pretty easy. All of these little hash marks mean that these segments are all congruent and 4 centimeters. So the area of this small circle is just 16 pi. I got the 16 by taking 4 squared. Then I'm going to move out to circle 2. The radius of circle 2 is 8, and when I square 8 I get 64. So the area of circle 2 is 64 pi. Moving out to circle 3, I have 4 plus 4 plus 4, giving this circle a radius of 12, and the area 144 pi. Area of circle 4, there's 4 plus 4 plus 4 plus 4, giving the radius 16, and 16 squared is 256 pi. Now if I do 256 pi minus 144 pi plus 64 pi minus 16 pi, it looks like I get 160 pi. Plugging that into my calculator, I get 502.65 centimeters squared. Moving on to example number 6, I'll notice that this is a square with 4 equal circles cut out. The square has side length 40 centimeters, so it will have 40 centimeters going up the side. I can confirm that it's a square because the circles are all the same size, and it's 2 circles by 2 circles. That doesn't look like a very good M. Alright, since it's 40 all the way across, the circles must have a diameter of 20 each, which would give the radiuses a value of 10 each. So my plan of attack here would be to find the area of the square and then subtract 4 times the area of one circle, because there are 4 circles that are congruent. The area of the square is quite easy at 40 times 40, and I'm going to do 4 times the radius squared times pi. So this is 1600 minus 400 pi. And when I plug that into my calculator, I get 343.36 centimeters squared. Okay? I hope this lesson made some sense to you, and your homework, number 9, if you didn't get it off my webpage, is on page 758. Numbers 8 and 9, 13, 16, 18, 24 to 31, and the quiz numbers 4 to 6.